Kia ora, whānau. We're back. We're doing another demo with the Raspberry Pi Pico. We are getting data from a sensor wirelessly. Okay, let's take a look at how to do that. A couple of things. I have my Raspberry Pi Pico here. It is plugged in. I have one of these, which is a DHT11 temperature and humidity sensor today. That's what we're going to be getting the data from. You see, it's one of these ones where it has 3 pins in, and it's got a little resistor here that helps with the circuitry. If you end up with one with 4 pins, it's slightly different. Not going to work today. Grab one of these ones with the 3 pins. You can find them nice and cheap in a lot of sensor kits and AliExpress and things. Okay, I also have 3 of these. I've got my Raspberry Pi Pico plugged into a breadboard. I make sure I've got a wireless one of these, and I have some jumper leads here, male to female. Okay, let's go. Let's start with the wiring today. How these work here is they have 3 pins. They have the data pin, the S pin, the sensor pin. I'm going to plug that into orange today. On it goes. It's a little bit hard with the camera so far away. The middle one is 5 volts, so I'm going to plug that into red today. And the last one, ground, for me, is going to be brown. Look at that. Okay, let's plug those wires into the Pico board. I'm trying to get this nice and close for you so you can see. In fact, let's get this nice and big. There we go. One more time, nice and big. We have S, which is signal on orange, middle one, 5 volts, red, end one, ground is brown. The colors don't matter as long as the connections are the same. Okay, correct at the other end. All right, signal for me today, orange, is going to go into GPIO pin 0. There it is connected. We're going to get ground into any of the ground ones. I'm going to pick this one today. Oh, that's going to be a bit tricky. There it is. And this one, red, is going to go into VCC, which is this top right-hand one here. There we go. And we are all connected and ready to go. Not much else happens visually with our Raspberry Pi Pico, so I'm actually just going to move him off to the side, perhaps even disappear him, to be honest, because there's not a lot to see. That's the setup. Okay, let's take a look now. We're in Thonny. We have the Microdot sensor Microdot library installed from our last demo, and we're going to set up a lot of what we did with our last demo pretty similar. So first thing first, we're going to do our importing. And now we need the DHT module. That comes built into MicroPython. So we should just be able to import it straight away. There we go. Okay, let's set up our WLAN, our WinLAN, our wireless local area network. Okay, let's set up a little infinite loop to wait for us to connect to the Wi-Fi. Once it has connected, let's get it to print out our IP address. You'll notice this is all pretty similar to our last demo. You can copy paste if you would like. Okay, here comes the fun bit. We're going to read in the data from that sensor. So to do that, we're going to use the DHT library. Ours is a DHT11 sensor, and we're reading that data on pin 0. So let's tell it that we're reading it off on pin 0, just like that. Fantastic. Let's set our app up, and we're using Microdot. still to do that. Cool. Now, what are we going to do when we get a request? Well, whoever's requesting wants the temperature and the humidity. So let's read the sensor, get that temperature and humidity data, send that back to the requester. When they give us a GET request on the root of our server, in the DHT library, there is something called measure, which actually gets the sensor data, and then we have to split it up by temperature and humidity, and then we can just return that as a response to the requester. So let's use sensor.measure. Let's get out the temperature. And getting out the humidity. Cool. Now let's put that in a reasonable response and send it back. Return. Let's make a little F string, and let's return the temperature. In degrees. Oh, how do we do degrees? Maybe we'll just go degree C. Let's put a little slash in there for a line break and say humidity. Our humidity is going to be whatever the humidity is, percent humidity. And that's it. That's it, we're done. Let's actually set our app running. Our host is 0.0.0.0. Oh, that's in a string, watch out. That's, again, in order to make sure that it accepts inbound requests. So when someone's requesting anything to our server running on our Raspberry Pi, we're actually going to let that come in, and then we're going to respond by running this code. We need to specify our port as well, or else it would default to something we don't want. There we go. I think we're good. Did we get it in one? Let's take a look. Let's run. Oh, invalid syntax. We did not. Import. 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 M-P-O-R-T. From Microdot import. Microdot. That looks better. We're still not there. 28. What have I done? We missed a comma. We missed a comma there. Hey, got it in 3. Fantastic. Let's head over to our browser. And I'm actually going to show you in my browser here. Internal server error. What's happening? We've got one more mistake. You'll see it down there in Thonny. Temp, T-E-M-M-P is not defined. Where is that in our F string? Okay, so when you're running a server, if you ever have a code issue, it's just going to say no, and you have to go and fix the bug. There we go. That does crash the server, so we need to rerun it. Reconnect the whole thing. Let's go back to the browser, refresh. Hey, there it is, fantastic. A nice balmy 19 degrees C and 61% humidity. Now, if I hold that sensor for a little second, then you might be able to see that temperature creep up. So there we go. I'm just going to grab that, stick it in my hand for a bit, and hopefully, as the sensor actually warms up, it might, there we go, creep up a little bit, maybe creep up a little bit more as we go as well. That might take a little bit of time. These temperature sensors are not straight away. They're designed for just detecting ambient room temperature. There are other ones that you can get very, very fast readings on. But there you go. We have a sensor connected to a Raspberry Pi, which is hosting a server on a wireless local area network, which we're then accessing on our computer, sending a request to the Raspberry Pi, which is reading the data, running the code on Thonny, and sending back a response. This is a fully fledged Internet of Things outcome. That's it for now. Ka kite.